All right, hi everybody. This is a video on topics 1.8 to 1.9, which is all about 5-number summaries, interpreting box plots, comparing box plots or distributions, outliers, and IQR. So I have attached I'm going to go through some of the notes for this, and then also I've attached this copy of the document and a blank one. If you would like to fill it all in yourself, I'm going to add to this because I think there's some things that are missing in here that we need to kind of talk about. So, so we have, let's say we take the height of people in a class. We have like a small class of 10 students, and these are their heights, 62, 63, all the way up to 71. So on the dot plot, I plotted those 10 heights. So this is recording our dot plot. This is our distribution of class heights. So this is our distribution, class heights. And the instructions for if we were doing the activity or whatever, we would order from shortest to tallest. So we have the data ordered from smallest to largest. So this is ordered. These are ordered heights, okay, from smallest to largest. And then here's our picture, right? Here's our representation of the data. Each individual dot represents one single person, right? So the first question is, what is the median of the height? Describe how you found it. So the median is the middle value, right? So you can go through here and say, okay, so this is 71, 62, and you kind of narrow your way to the middle once they're ordered. Once we do that, just kind of checking them off. Okay, once we get to the middle here, there's nothing left. So the median is whatever the average of these two are, 65 and 67, or in other words, what number is exactly halfway between 65 and 67. So the median is, for our data set, the median is 66. So the median, try to find the best place to put up it here. The median is 66 inches. Okay, and describe how we found it. This is a good description. If we have an even number of values, so we have 10 heights in our case, we find the average of the middle two values, and that's what we did. So we did 65 plus 67 divided by 2, that'll get you 66, or you can just think what number is exactly between 65 and 67. That is, but you could find the average of those. If it's an odd number of values, it's just the middle of the values. So if I added one more height in here, like let's say I added in 73, then 67 would become the median because it'll just shift down one more spot in that order. Okay, so this is your description. So if it's an odd number of values, so we find the middle value. If it's an even number, you find the average of the two middle values. And you could use like this sort of cross-off method to even get in to find those middle two if you would like to. So the median, how do we interpret it? So the interpretation of the median, and again, I don't have a lot of room to write this down, and it's not part of the question, but I think it's important. This just means that half of the students in this class had a height less than 66 inches. So 50% of the students were shorter than 66 inches, and that's also true for students taller than 66 inches. Okay, so now what is Q1 and Q3? Q1 and Q3 stand for quartile 1 and quartile 3. Q1, this is the 25th percentile, and Q3 is the 75th percentile. So we can define them also as the median of the lower half. So if you think about that, if you take the lower half of your data, that's the bottom 50%, the middle of that would be the 25%. And if you take the upper 50%, the middle of that upper 50% from 50 to 100% would be 75. So we say that Q1 is like looking for the 25th percentile and Q3 is looking for the 75th percentile, okay? So how can we find that? And let's look at our data set. So we have to look at the median of the lower half. So here's my lower half. We don't include the median in this. In our case, 66 is not part of our data set. So we just use the bottom half here, but you just go for the median of the bottom half. So we have 62, 65, 63, 64. It looks like Q3 or Q1 should be 63. And then over here, the top half, we have a top, bottom, okay, narrow your way. Okay, 68 is the median of the upper half, so that's Q3. And it said, just a little note in here, if the median, so that this only applied for an odd number of values in our data set. So we have an even, but we do not ever include the median as part of the upper or lower half. So wherever the median is, you ignore it when you find the quartiles. Okay, so It's always just looking at the data above or below the median, excluding whatever that median number is. But Q1 is just the median of the bottom half, and Q3 is the median of the top half. So this just means that 75% of the data is at or below Q3, or 68, and 25% of the data is at or below 63 inches. So in our case, the students in our class, their heights. So that's how you find the Q1 and Q3 of your data. Record the following values and then use them to make a box plot. Okay, I'm gonna try to do this in a couple different colors. So what's our minimum height? The minimum height was 62. Q1 was 63. The median was 66. Q3 was 68, and the max is 71. So I'm going to draw my box plot over this one here, and we'll do similar markings or something. So 62 would be my minimum. We're 63, so that would be one part of the box plot, one end of the box in the middle. So we have this whisker right here that goes to that box. 63, the median is 66, so I'd have a bar here for the median, and then 68 would be Q3. So here's our box in the middle. Okay, and then where's our highest? 71. So there's 71, so we would have that as 71, okay? So this would be our box. So for us, the IQR, I'm gonna put this in red. The IQR is the range of the middle 50%. So it's right here. This is your IQR from Q1 to Q3. And then we're going to look at outliers in a second here, but 1.5 times the IQR. So outliers are beyond whatever 1.5 times the IQR is. So in our case, it should go out a little bit to 68. If I add another IQR onto here, so I take this distance and I tack it on. So what is that? The IQR for our data set is 68, 63, so it's 5 inches. If I add another 5 inches, so that takes me to 73. It's another 5 inches. And then it's 1.5 times the IQR, so I need a half an IQR, so it's 2.5. So here, okay, anything beyond here are outliers. This is equivalent to Q3 plus 1.5 times the IQR. Okay. The other direction was subtraction, was Q1. Now I need to go 5 units, so 1 IQR this way. So 63 to 58, it's 1 IQR. Then go a half an IQR, so 1, that takes you to 57. And we'll need to 56. Then we need to go down a half to 55.5. So 2.5 units this way. At this point right there, anybody who's shorter than 55.5 inches is an outlier, but we don't have that we don't have anybody in our data set. So we actually have no outliers. This little part is Q1 minus 1.5 times the IQR, okay? And that's our lower limit for outliers. This is our upper limit for outliers, and that's where we check it. So the IQR is what we already talked about. It's Q3 minus Q1. It is 68 minus 63, which is 5 inches. And the IQR is the length of the box, but the interpretation that we need to know, like what does this actually mean? This means that the range of the middle 50% of, what are we talking about, of heights, need context, for this class is 5 inches. That's what that means. The range of the middle 50%. So the length of that box is the IQR. We should always talk about the IQR when we're talking about box plots. So if we have some that are way too small, way too high, these are our outlier bounds. This is your lower limit right here. This is one we learned about. Lower limit, upper limit. It's always strictly greater than or less than. So you can't, like if you're exactly at that number, it's not considered an outlier, but you have to be less than or larger than that. And then if there are outliers, we change the box plot to show outliers as stars. So for example, let's say for our class, I had a person who was 78 inches tall. You add that person in. On my box plot, I would add a little asterisk for 78. They would become the max of my data set, and 71 would be the next highest height that is not an outlier. So 78 would be our outlier. We usually add an asterisk. Some people just use a dot, a star, whatever you want to do. So a star, another big dot, you can use an asterisk, whatever you want to do, but you isolate it, any outlier like that. And that could also be true for 77. If I had a person who was 77, I'd put a little asterisk or a dot right there too. And then if we had somebody shorter than 55 and a half, let's say 51, or 54 or something, they'd be way out here. We have another dot representing them. So that's just how we construct your box plot. And then what I want to highlight here before we move on is as it's noted here, this set of 5 numbers, the minimum, Q1, median, Q3, and maximum, they are called the 5-number summary of your data set. So we use those 5 numbers to make your box plot, and then also any outlier calculations that we do. But this is called the 5-number summary. So if I ask you and I say, give me the 5-number summary of your data set, that means minimum, Q1, median, Q3, and maximum. So you need all 5 of these to describe the 5-number summary of your data set. Okay, so let's, so big things to take away here. We need the 5-number summary. That's what's used to make a box plot. In addition to outliers, way too small. So this is your lower limit. And this is your upper limit, and then way too big. In other words, typical and not typical. Outliers are not typical. Remember, this is a different acronym. I showed you CUS plus context. So make sure you're always talking about center, unusual individuals, which are like outliers, shape, and spread. So that's what we're going to be looking at here when we do some describing of your distributions. And that's what we're doing right here. So here's some box plots. The following box plots show the income of 40 randomly chosen households from each Connecticut, Maine, Massachusetts, based on the U.S. Census data and the community survey. So this is, think of this as we have a sample from each state. And then we want to compare the distributions of annual incomes in the 3 states. When we compare, we have to use words that are comparison words: greater, like greater, smaller, less, more. Anything that compares those words. You can't just list, okay? You can't just list facts you know about these distributions. You have to include something about how you compare: greater, smaller, less, more, higher, lower, something. Using symbols showing greater than, less than. That's all good too. Okay, that's all fine. You could write it like that too, but we got to compare those. And we're going to compare all 4 aspects of CUS. Okay, so let's take a look. The question is just compare the distributions of annual incomes in the 3 states. So let's look at the how this person would have compare these distributions. So what are some things you notice? First of all, you see that Maine and Massachusetts have outliers, but Connecticut doesn't. Another thing that stands out to me when I first look at this is that Massachusetts has a long whisker right here, whereas Maine and Connecticut do not have that. So maybe that's something we need to point out when we compare. Other things I see are the minimums are pretty close to each other. They're not that far off. But the medians are different. Like the Maine has a smaller median than Connecticut, which has a smaller median than Massachusetts. And then we also see the interquartile range. The length of this box is fairly similar for Maine and Connecticut, but Massachusetts is a little wider. So what does that mean? This, like, just in general, there's more variation in Massachusetts, so like greater spread, than either in Maine or Connecticut, okay? Maine and Connecticut are fairly similar. Connecticut's got a little bit more variability than Maine when it comes to the middle 50%, but Maine has those outliers. So let's see what you can compare. So first of all, they started with shape. So that's one part here that we need to highlight. The shape of the distribution of income. So you've already talked about context. It's already established. So you need to mention what you're talking about. Distribution of income for Connecticut is roughly symmetric. This is pretty symmetric box plot. While Maine incomes are slightly skewed right, and that's because of this outlier. And Massachusetts incomes have a stronger right skew. Okay. And we note that it's hard to tell shape of the box plot, but we can talk about some shape in here if we would like. This is definitely more skewed to the right. So they've already compared shape. So shape is done. The center, so that's the C. The center is highest for Massachusetts, followed by Connecticut, then Maine with the lowest. So it's highest, lowest, comparison words. So they compared center. I'm going to add in here that I would prefer to say for center, I would prefer you to use the word median, because the median is what we see in the box plot. So we're referring to this right here. And if you're ever worried, you can give those numbers and just compare them and say, like, the median for Maine is about 49, which is less than the median for Connecticut of about 53, or maybe more, 60, and then $60,000. And then Massachusetts has the highest median at about $100,000. And we should be talking in thousands of dollars here. So, but that's what I would prefer you to say. But either way is totally fine. The variability is highest for Massachusetts, with Maine and Connecticut having similar variability. The reason they say it's highest is because of the length of this box. The length of this box right here, but the whole plot is just definitely more widely spread out. So one thing I would add here, so this is variability. This is spread. One other thing I would add here is this is talking about, I would add in specifically talk about the IQR, which is the length of the box of each of these. So Massachusetts has the highest IQR, so the highest IQR, with Maine and Connecticut having similar variability, similar IQRs, the range of that box, the distance, the length of that box. I would talk more about the IQR. Would probably improve the response. Maine and Massachusetts have a high outlier, while Connecticut has none. Perfect. That's great. So there you go. You talk about this one has outliers. These two have outliers. The other one doesn't. So just right there, I can tell you from scoring some of this stuff. Center, center, spread, shape. Those are the three big ones that need to always be compared. Outliers just depends if there are any, but you should be looking for the outliers too, or unusual individuals. So keeping that in mind. So that's where we have our cost plus context. So this person would have hit all of that. So a little bit of comparisons. I've been impressed with our comparisons when we do our Desmos activities, and how we're talking about the distribution. So continue that, but this should be a good example of how you can write a good comparison. If you have any questions, please reach out and ask. That's what I would ask out of you. Hope you have a good day.